Good morning, students. Now we are going to discuss about pair of straight lines. In previous classes, we studied very well about straight lines. Now we are going to discuss pair of straight lines. It is a very important chapter in our IPE exam. In this chapter, two 7 marks questions will be occurs. So, to a 7 or 14 marks easily we can get very important problems we have to solve. Now, I will explain briefly about the theoretical part. What is the pair of straight line and regarding applications, theorems, so that we can move. Now we know already if a1x plus b1y plus c1 is equal to 0, let L1 is equal to and L2 is equal to a2x plus b2y plus c2 is equal to 0, another straight line. With these two straight lines represent two straight lines in a plane. Here now, here a1, b1 is not 0 at a time. Okay. Similarly, a2 and b2 not 0, not equal to 0 at a time. Then only these two straight lines represents two straight lines. Okay. Now consider an equation, an algebraic equation a1x plus b1y plus c1 into a2x plus b2y plus c2 is equal to 0. This is nothing but the product of a1x plus b1y plus c1 into a2x plus b2y plus c2 is equal to 0. It is if we multiply these two, it is a second degree equation in x and y. If let this is a locus of any point, if p x1 comma y1 or alpha beta is on the locus, that implies instead of x we have put alpha and instead of y we put beta, that implies a1 alpha plus b1 beta plus c1 into a2 alpha plus b2 beta plus c2 should be equal to 0. Since we take that, we assume that p alpha beta is on the locus. Okay, on this locus this is 1 on 1. So instead of x we put alpha and instead of y put b. That implies if the product of any two numbers is equal to 0, either first one is equal to 0 or second one equal to 0. If ab is equal to 0, then a is equal to 0 or b is equal to 0. By that logic, that implies we can write a1 alpha plus b1 beta plus c1 is equal to 0 or a2 alpha plus b2 beta plus c2 is equal to 0. That means alpha beta belongs to either L1, which represents L1 equation on the first straight line, or alpha beta belongs to second straight line. That implies P alpha beta lies on either L1 is equal to 0 or L2 is equal to 0. We can calculate that. Okay. Then we can conclude that P alpha beta lies on either L1 is equal to 0 and or L2 is equal to 0. So that we can conclude that the first one, that means the locus of the point, the curve, maybe the combined equation of L1 is equal to 0 and L2 is equal to 0. That implies the combined equation of L1 is equal to 0 and L2 is equal to 0 is the locus. That means a1x plus b1y plus c1 into a2x plus b2y plus c2 is equal to 0. So we can conclude that the combined equation of the L1 is equal to 0 and L2 is equal to 0 is the a1x plus b1y plus c1 is equal to 0 into a2x plus b2y plus c2 is equal to 0. It is a second degree. Similarly, you take an example. Let us take, let L1 is equal to 2x plus 3y, L2 is equal to x minus 4y. Then, how can we find the combined equation of L1 is equal to 0 and L2? Therefore, combined equation of L1 and L1 is equal to 0 and L2 is equal to 0 is the product 2x plus 3y into x minus 4y is equal to 0. If we simplify, we can simplify. That means 2x square 2x into x minus 2 4s are 8xy plus 3xy plus into minus 12y square equal to 0. So 2x square minus 5xy minus 12y square is equal to 0. This is the combined equation of these two straight lines. Okay. Whether it may be curve or intersecting lines or any other. Okay. Here we can say that 2x plus 3y is equal to 0, x minus 4y is equal to 0. These two straight lines are passing through origin only, since there is no constant. If ax plus by plus c is equal to 0, then it does not pass as, if c is not equal to 0, it does not pass through origin. But here it is in the form of ax plus by is equal to 0. So these two straight lines are passing through 0. So the combined equation also passing through. The graph may be like this. Combined equation may be like this. This is the A, B. Let AOB. AOB is the equation of combined equation of L1 is equal to 0 and L2 is equal to 0. Now we have to discuss some other point here. What is that? Let h is equal to ax square plus 2hxy plus by square is equal to 0 is the homogeneous equation in second degree. Homogeneous equation with second degree in the variables x and y. Okay. It represents a pair of straight lines if the it is in the form of pair of straight lines which are passing through this is A, O. The combined equation of OA and OB is h is equal to 0 is h is equal to 0. That is the first point we have to remember. The second one, if s is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 is the general equation in second degree in the variables x and y. This also represents a pair of straight lines which are not passing through origin. That means these are like this method. Let P Q R, Q P Q R. Then S is equal to combined equation of let L1 is equal to 0. This is L2 is equal to 0. The combined equation of S is equal to L1 is equal to L1 into L2 is equal to 0. Here OA into OB is equal to 0. In that way we have to discuss further. Is there any condition for second degree equation represent a pair of straight lines? Yes, there is a condition, that is, in this case, if h is equal to 0 to h is equal to 0 represents a pair of straight lines, the condition is h square greater than AB. H square means 2h means x is the coefficient of xy, a is the coefficient of x square and b is the coefficient of y square. Then the condition is h square greater than AB or h square minus AB greater than 0. This we have to verify. Okay. In this way we have to verify in the general equation also. It represents a pair of straight lines which are not passing through origin. But h is equal to 0 represents a pair of straight line which are passing through origin. That is the main difference between h is equal to 0 and s is equal to 0. H is equal to 0 is nothing but ax square plus 2hx plus by square is equal to 0 and s is equal to 0 implies ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. These also represent a pair of straight lines. There is a condition also, conditions are applied for that. Further we have to discuss further conditions. Okay. Now we go to further point. Now we are going to discuss about only the homogeneous equation, that is h is equal to combined equation, that is h is equal to 0, which is homogeneous equation, second degree equation. Let h is equal to ax square plus 2hxy plus by square is equal to 0. Represent a straight line to the condition is h square greater than a. Okay. If here we have to discuss on another point, second one. If h square is equal to AB, then the two straight lines coincident with one another. Okay, that means these two straight lines may be like this. This is OA. First one L1. Another one is also OB. Okay, that is in that way, if h square is equal to AB, the lines are coincident lines. You have to remember that point. Okay. Next one, if h is equal to a square plus 2hxy plus by square is equal to 0, represent two straight lines. Represents two straight lines with slopes m1 comma m2. Then the equations may be taken as L1 is equal to y is equal to m1x, L2 is y is equal to m to x. The difference is only slopes. That implies y minus m1x is equal to 0. That implies y minus m2x is equal to 0. These two are the lines individually with slopes m1 and m2. We have to discuss the relation between slopes and the given equation, homogeneous equation. If we take this represents these two straight lines, then we can write if h is equal to 0 represents L1 is equal to 0 and L2 is equal to 0. That implies ax square plus 2hxy plus by square can be written as y minus m1x into y minus m2x. You have to remember this. If we multiply these two, y into y square minus m2x minus m2xy minus m1xy minus plus m2y square. This can be written as y square minus of m1 plus m2 xy plus m1 m2 x square minus m1 into m1x into minus m2x means m1 m2 x square. That means m1 m2 x square. From right side point of view, here y square, the quotient of y square is 1. So that we have to divide this by taking b as common. It implies b into a by b x square minus 2h by bxy plus y square is equal to y square into y square minus of m1 m plus m2 xy plus m1 m2 x square. Okay. Okay. Further, by comparing both sides, now here you take is equal to some constant b into, then it will become b into. Now this b divides, if we bring that, it divides b like this. Comparing both sides, we have the coefficient of xy, because here coefficient of xy is 2h by b, that implies minus of m1 plus m2 is equal to 2h by b, that implies m1 plus m2 is equal to minus of 2h by b. This is one relation. And the quotient of x square, here quotient of x square means a by b, that implies m1 m2 is equal to a by b. This is the second relation. By using these two relations, we can find the slopes of two straight lines separately by the given homogeneous equation. We have to use these relations in our problem solving. Okay. The sum of slopes is equal to minus 2h by b, and the product of slopes is equal to a by b, where ax square plus 2hx square plus by square is equal to 0. Represent a pair of straight lines with slopes m1 and m2. Okay. Next point, we have to go. Here we will further go to prove a theorem, that is nothing but if the the angle between two straight lines represented by h is equal to 0 is theta, then we have to find how to find the angle between these two straight lines. That means here we have to write, if let h is equal to ax square plus 2hxy plus by square is equal to 0 represents two straight lines and angle between them is theta, then cos theta is equal to mod of a plus b by root of a minus b whole square plus 4h square. This is the relation we have to prove. Main important theory. It will give in our public exam also. It may be taken 4 marks and another bit will be second one in 7 marks, 4 marks this much, and a problem depends on another part is 3 marks. Also a very important problem. Proof. Given equation is h is equal to ax square plus 2hxy plus by square is equal to 0. If it represents, say, the lines represented by h is equal to 0 are L1x plus M1y is equal to 0 and L2x plus M2y is equal to 0. Okay. Just write. L2 M2y is equal to 0. Then that implies ax square plus 2hxy plus by square is equal to L1x plus M1y into L2x plus M2y. On multiplication by simplification of this part, this can be written as L1 L2 x square plus M1y into M1y M2y square. The remaining L1x into M2y, L1 M2xy, next L2 M1 xy. By taking xy as common, this can be written as L1 M2 plus L2 M1 into xy plus M1 M2 y square. Okay. By comparing both sides, L1 L2, the coefficient of x square is equal to a. Similarly, coefficient of y square M1 M2 is equal to b, and the coefficient of xy is L1 M2 plus L2 M1 is equal to 2h. We have to put. Okay, by using this, if we in straight lines, we know the formula for finding if two straight lines a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 are intersecting lines and angle between them is theta, then cos theta is equal to a1 a2 plus b1 b2 mod of a1 a2 plus b1 b2 by root of a1 square plus b1 square into root of a2 square plus b2 square. By using that formula, if the angle is theta, here theta is the angle between straight lines, then cos theta is equal to, take these two straight lines, a1x plus b1y plus c1 is equal, c1 is not there, and a2x plus b2y. Take these two, this one and this one. A1 instead of A1, there L1 is there, A2, L2. That implies mod of L1, L2, A1, A2, B1, B2. That means M1, M2. Mod of by root of A1 square plus B1 square. That means L1 square plus M1 square into root of A2 square plus B2 square. Similarly here L2 square plus M2 square. Okay. By simplification we have to reach this much. Here this denominator should be greater than 0. Since it is under root, it is obvious that a minus b whole square plus 4h square is greater than 0. Since it is under root, so it is now greater than 1 should be. Belongs to A, B, C, H, A, B and H belongs to R. So this should be greater than 0. And if it is in under, that means denominator, it is not equal to 0. So it should be greater than 0. By that we can simplify, that is equal to L1 L2 plus M1 M2 by, how can we simplify this numerator to get that a minus b whole square plus 4h square? By multiplication, by multiplying this L1 square L2 square, next plus L1 square M2 square plus L2 square M1 square. By multiplying these two, next M1 square M2 square. Okay. By rearranging the terms, this can be written as that implies cos theta can be written as L1 L2 mod of L1 L2 by, in denominator we have to arrange these two terms at once. L1 L2 whole square plus M1 M2 whole square. Okay. Similarly these two terms plus L1 M2 whole square plus L2 M1 whole square. So by observing this, it is in the form of a square plus b square. If 2ab term with plus either plus or minus, if plus is there, a plus b whole square will be there. If minus is there, it should be a minus b whole square. So we have to further plus 2L1 M2 L2 M1 by adding for this. It is now it becomes in the form a square plus b square plus 2ab. So it is a plus b whole square. We added these two and we have to subtract minus 2L1 L2 M1 M2. Okay. Under if we add these to this part, a square plus b square minus 2ab. So this can be written as cos theta is equal to mod of L1 L2 plus M1 M2 by under root, this can be written as L1 L2 minus M1 M2 whole square plus this can be written as L1 M2 plus L2 M1 whole square. Okay. By substituting this value, that means L1 L2 is equal to A and M1 M2 is equal to B and L1 M2 plus L2 M1 is equal to H, it can be written as cos theta is equal to this, instead of this one a plus b, mod of a plus b by under root a minus b whole square plus L1 M2 plus L2 M1 is equal to 2h. 2h whole square means 4h square, which we have to prove. Hence, prove. In this way, we have to prove the angle between theta, two straight lines is theta, which are represented by h is equal to a square plus 2hx square plus by square is equal to 0. Then the angle between those two straight lines is maybe obtained by using this formula a plus b by root of a minus b whole square plus 4h square. In terms of sine, in terms of tan, also we can find. That's also we have to prove. That means if cos theta is equal to, therefore we know that sin square theta is equal to 1 minus cos square theta. That means 1 minus a plus b whole square by a minus b whole square plus 4h square. Squaring of cos theta. Okay. If we simplify this can be written as a minus b whole square plus 4h square minus of a plus b whole square by a minus b whole square plus 4h square. This can be simplified by a minus b whole square minus of a plus b whole square is equal to a square get cancelled, b square get cancelled. So minus 4ab. Here minus 2ab is there, here minus of 2ab is there. That means 4h square minus 4ab by a minus b whole square plus 4h square. By taking 4 as common, 4 into h square minus ab by a minus b whole square plus 4h square. Now we have to find by using sin theta. We can write therefore sin theta is equal to square root of 4 into h square minus ab by a minus b whole square plus 4h square. That means if you bring out 2 root of h square minus ab by a minus b whole square plus 4h square. In terms of tan, we can find also. Therefore, sin theta, tan theta is equal to sin theta by cos theta. That is equal to what is sin theta? 2 root h square minus ab by a minus b whole square plus 4h square whole divided by what is cos theta? Mod of a plus b by a minus b whole square plus 4h square. Denominator can cancel. That means the remaining is 2 root h square minus ab by mod of a plus. By using this formula also we can find the angle in terms of by using tan formula. Okay, we have to use cos or sin or tan, anyone